Hey there, everyone. Ryan Schul, Straight Data Science. Welcome to my channel. So, for the topic today, I want to talk about creating a carbon footprint tracker, and we are going to base everything on zip codes around the United States. Okay, and at the end, I'm going to aggregate everything up to a state level so you can see what the total state carbon footprint is. Okay, so why do we even want to do this type of analysis? This is a multifaceted type of answer. Basically, for targeted climate action, okay, we can look at zip code level data and understand the emissions, and are they increasing, are they decreasing, what are the emissions by zip code, and how dense or how non-dense are the emission patterns in certain zip codes, right? And with this data, we can understand behavioral and socioeconomic drivers, income, commute times, home sizes, household behavior, how much waste does a household create, things like this. That's what we're going to look at. We can promote climate equality, right? This helps identify communities with high emissions, but low access to clean technology like solar power, wind power, hydropower, things like this. We can inform policy decision makers, urban planning, architects, utility strategy, concepts, and any kind of legislation related to that. Okay, we can do city planning and utility production and the modeling and the utilization of those. We can make that more optimized and more efficient. We can track progress over time. We can look at local governments and understand, based on the zip codes, how to set emission targets or how to try to cap emissions from different zip codes, right? And also to engage citizens with localized data, because this is specifically pertaining to them. This is directly relevant to the people that live inside of these zip code borders, right? People are more likely to care about what they can see and have a direct impact on. Okay, and if my zip code emits 22 tons of carbon per year, and this is higher than my neighbor's zip code, how can we correct this action, right? So we can almost create like a competitive sort of vibe to this type of thing, and how people ultimately to lower their carbon emissions. Okay, so on average, there are about 33,000 zip codes in the United States, just over 33,000. Basically, you have the 5-digit zip code that can start with a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It has 5 digits. Some of the more specific areas or delivery locations actually have an extra 4 digits on the zip code. We don't really get into that, but I guess that's good to know. Zip codes are used for more than just mail. They're also used for statistics, marketing, and even internet applications. Okay, so that's important to know. And we're going to create a choropleth map similar to this one. So this was the motivation for my analysis. I found this about 2 days ago, and I thought this was kind of cool. And I said, okay, I'd like to be able to reproduce this map. How can I do that, right? So that's what I undertook, right, on my own initiative. If I zoom in here, I can see New York City. This is where I live, and I can see my exact zip code, 11101. Sounds like the first zip code ever, 11101, and we have 31.6 carbon tons of emissions output per year. Okay, so basically, if we zoom out here, we can see the entire United States. I'm not an expert here, but I think the zip codes start in the Northeast. If we go over here, I see some low numbers over here, 04, 07. This one's a little bit redder, so they have a little bit higher carbon emission, 48.8, 04, 745, 04756, and 04746. These guys are a little bit lower. Okay, so anyways, zip codes start in the Northeast, and I think they continue down the East Coast, and they wrap around Florida or something like that. And I think they end in the Pacific Northwest, because you see some high numbers over here. We start with the 04s on the East Coast, then we get to 98357, 38.3 emission. This is higher emission over here, 67.9. So this is more of an urban area, I believe, and maybe an industrial area. And then you have some higher emission zip codes over here, 54.2, 54.1, 52.4. So anyways, that was the motivation for the analysis that I undertook. So if we jump into it, I can actually download some historical ZCAT5 data, which comes from over here. Okay, if I hit enter, I can download this right here. I'm going to not download it because it's actually already downloaded. This is in my desktop, and it is called all files. So I put all the files into this folder called all files. So the interesting thing about this is it has a shap file. So this has all the shapes of all of the geometric patterns for all the zip codes throughout the United States. That's what the shap file is. And apparently there's some dependencies over here with some of these XML files, PRJ, DBF, and CPG, I guess, because I tried to run this just on the shap file and it didn't work. It's giving me an error message saying that it needs all the other files as well. So as long as all the files are in the folder, you can go ahead and run this. You can put some padding on these zip codes because some of these will actually come with the leading zeros truncated. So if you start with a 0, like we saw in the Northeast, you would actually have 4 digits, right? They append the 0 onto the beginning just to create a 5-digit zip code, right? So we have to pad this and force these zip codes to be 5 digits if they're not. And this is what it looks like when it's printed out. Okay, so now we have all the zip codes, and I can go ahead and print the number of rows, and we have about 33,144 zip codes in the United States. So I got one more source of zip codes. This came to me from here. So I put the URL in here, put the other URL too. So you have that. That's where you can get the shap file and all the dependencies. This is where you can get all the zip codes. And I see here we have 33,782. So slightly more than this 33,144, slightly more granular perspective, I guess. And it is what it is. It's about 33,000. I have 33,100 here, 33,700 here. As long as we have good coverage, I think it's fine. These are the zeros I was talking about before. You have to pen these on to the beginning of the zip if it doesn't exist, okay, because the leading zeros will be dropped off. And if we just do a quick sanity check here and Google it, zip code, it says Adjunitas, Puerto Rico. And if I go over here, I see Adjunitas, Puerto Rico. So I think everything's fine. So we have the zip codes. We have 33,700, 33,100. I don't think it really matters how many zip codes we get. As long as it's over 33,000, we have good coverage here. So I want to go ahead and look at zip codes, income, commute minutes. Now this is synthetic data that I created. I couldn't find the actual data I was looking for. I was looking for data related to zip codes and showing me commutes and household sizes and regional factors. I couldn't find it, so I created it, okay? So this is pretty realistic, but it is, why is that MP? Okay. Okay, it's complaining about this. All right, now you're happy, right? So we have the zip codes. Now I just want to get a quick visual understanding of what we have here. So here's the zip code. It's repeated. I'm not sure why. Then we have a classifier. This is some kind of geocode over here. I'm not sure what that is. This looks like geographical, geographical long coordinates, right? So it's -83, 615, 41, 318. And I can prove that if I go to Puerto Rico, maps, just generally speaking, okay, Puerto Rico. And let's see what kind of zip codes they come back with. Okay. Here, I'm not even sure. I'm not even sure what this looks like. Oh, wait, maybe, what was that thing called? What was that? Adjunitas. Okay, let me just look at this thing on the map just to see what we're dealing with here. Okay, Adjunitas. It's there. It's definitely there. So, okay, it's not giving me any zip codes there, but that's fine. It's part of Puerto Rico, and it's called Adjunitas. So anyway, so we go back to the data set. I think I just ran this. Let me just do it again just to make sure. And here's the GDF data frame. If I look for this, this actually comes from here. So this is the shap file that I originally imported. This is global data frame. I think that's what the abbreviation was. I forgot what I named that for, GDF. And then we have another DF zip, and DF zip comes from over here. Put that in there. Then we have the DF, and that comes from this data frame that I created over here. Okay, so everything looks fine. I'm going to go ahead and merge these two right here. So GDF is merged with data frame on zip. So we blend these two together, and we are creating the join right here, left join. If I go enter, oops, I need to hit that, control enter, 33144. So in this case, it doesn't matter. All these zip codes match. If I did a left, right, or enter, probably get the same amount, 33144. Yeah, so everything is exactly the same. So left, right, or enter, it doesn't matter. I like to use enter. Everything that matches shows up. Left is going to show you everything on the left and all the rights that match up, and right will do all the rights and all the lefts that match up. Okay, so pretty standard stuff. So now I'm going to go ahead and create a Folium map. Folium maps are very useful for all kinds of different things, for plotting, charting, geographical, latitude, longitude coordinates, all kinds of different stuff, right? So I want to go ahead and create a simplified map, simplified, and this is going to be based on geometry. If I show you where this goes, it goes to map df sample, right? Simple or sample, basically same thing. So that's going to be the source data for this. And we're looking at 10,000 different zip codes. So the point of this is to make the map render faster and generate faster than if I used all 33,000 zip codes. That's going to take a little bit longer. If you need all 33,000, and I'll actually do that a little bit later, I'll get all 33,000. That's totally fine and well and good. If you just needed a subset of this, this whole population, this whole geographical layout of all the zip codes, then you could get it this way, right? Just taking a random sample, and we'll see how the map is rendered down here. We'll see that this uses GeoJSON data. So JSON is short for JavaScript Object Notation. This is just the way that all the data is rendered, right? So it's rendered as JavaScript, and it looks a little bit funky if you look at it, but it's actually a very efficient way to store and to retrieve data, and computers can process this JSON data seamlessly and very quickly and effortlessly, right? So even though it looks kind of weird, when a person reads it, it's a very efficient storage medium. So it's pretty popular to use this data format. Okay, so this is going to load up into GeoData, and the map comes from df sample. Okay, so that comes from here. You can see the df sample is right here, and that is the first 10,000, or not first 10,000, but a random sample of zip codes across the country, 10,000 zip codes. Okay, so I think the map is rendering. This does take a little bit of time. I did this yesterday, and it showed up in a couple of minutes. It does take a couple of minutes, however, though. And I had to redo this video, by the way, because there's no sound. I don't know what happened yesterday. The sound bar was bouncing up and down. I'm looking at it right now, it's going up and down, up and down. So it indicates to me that it's working fine. However, when I posted the video, there was no sound. So I don't know what happened between recording the sound and posting the video, but somehow the sound got stripped. So I had to redo this. So that's how we got here. So just waiting for this thing to render, and then I think I'm going to go ahead and actually get all the zip codes and put everything into this this whole package here. So if I do Control F, I can see map simplified to JSON. I want to put that into GeoJSON, and map df sample. I want to map that. And then of course the two columns I'm looking at is zip and total carbon footprint. And if you look closely, that comes from over here. Here's the zip code, right? Actually, it matches that. So you can use any one of these columns. That's the ZCTA code, which matches that, and it matches that. So you can use the zip code. We have income, commute minutes. This is the time, the average time to commute to work for the people that live in this zip code, and the average is just an average. Some people will be more, some will be less, right? Household size, based on the household size, the regional factor, and the noise that is emitted in this area, we can calculate total emissions. So we have transportation emissions. This is going and coming back from work, going to work and coming back. Home energy emissions, this is directly related to the size of the house, right? The bigger the house, the more the emissions, presumably, not always, but pretty much that's the rule. And then waste emissions. So this could be like garbage, recyclable, non-recyclable waste, things like even was it fertilizer or compost, things like this. That's not going to create a whole bunch of CO2 emissions, but there will be some, right? So we can sum all these together and get the total carbon footprint. And again, that's the sum of this, this, and this. So transportation emissions, home energy emissions, and waste emissions. Okay, so let's see how the map is doing. Still working. So that is running, presumably, hopefully. Okay, we'll give that another one more time here, another few seconds or whatever. Hopefully this finishes off pretty quick, and then we can move on. I was hesitating to even run this thing, just use the previous run. I wanted to show you that the code actually works and that doesn't just look pretty, that it actually does something too. So that was my intention here. Let's give it a minute. Hopefully it responds something favorable. Okay. And again, if you look at this, we're just putting in the inputs into geographical data. This is the GeoJSON. This is the data. That's the sample data that we came up with. The columns are zip and total carbon footprint. Key is the feature properties with the zip code. The fill color is yellow, orange, and red. Okay, so you'll see like some brown tint in there too. Yellow, orange, and red are the main ones. Fill opacity is 0.07, so somewhat opaque. Line opacity is 0.02, so more opaque, the more translucent it is, right? And the darker the color, the more filled in it is. Okay, so there's the 10,000. And the next one is running with all the records. Okay, so instead of just 10,000, we can see everything. And if I put my mouse over the FIPS data, this is, I'm sorry, zip data, this is not FIPS. FIPS is something different. If I put my mouse over the zip code data, you can see the details here and then the carbon emissions from each zip code. So I see 10075, this is Manhattan. These are my neighbors over here, 10.2, 13.74 for 10021. If we go down here, 10009, 12.17. This is metric tons emitted. Carbon footprint, metric tons. This is a little bit higher, 15.9. These guys are dark red, so this is even higher, 17.7. This is probably the Bronx, 10471. If I Google that, let's see, Google 471, right? Zip code Riverdale, neighborhood of the Bronx. That's what I thought. 10471. That's what it looks like. And this is what it looks like on the map. And the neighbors over here are doing about 13.37 metric tons and 12.03, 10470. So it should be right next door, right? 470. And indeed it is 10470. This is Bronx, New York. So it's just called Bronx. The other one was called Riverdale. Okay. So the main point is we have 10,000 different zip codes rendered and displayed in this geographical map, this Folium map right here. We have a few things down in Cuba because we have some zip codes down there, right? And Hawaii actually got picked up too, and they have carbon footprint about equal to New York. So that's interesting, 13.6. Even these guys over here have 13.12, right? So we have pretty much the entire United States covered, even Alaska, but there are some gaps in here you can see because we only got the 10,000. I wanted the map to be displayed pretty quick, but I had a change of heart here and I actually want to see the full display with all the zip codes filled in. Okay, so that's what we're getting here. And again, this data comes to us in the form of JSON strings, right? If I put that in here and show it, this is what it looks like. So that's what I said before. It kind of looks funky. You have all the lat long coordinates right here, and then all the relevant zip codes. Not fun to look at, but again, if you feed this into the computer, it is going to interpret this very quickly, very easily, and decipher that effortlessly. So you can see all of the lat long coordinates and all the zip codes rendered perfectly on your map, right? So JSON data is great for storing and retrieving data, not great for reading for a person, but it's great for the computer. So as I move down here, I'll move down to the next cell. We can come back. I can discuss this in a minute. I have another file called US zips over here. So this is saved on my desktop. This is what this file looks like. If I open it, you will see, what is this? The state and the state ID and the zip code. I believe that's what this is. And it's opening right now. Okay, so we got a bunch of stuff here. So the zip code, and you can see this leading zip codes. The zeros are truncated. That's just the way it comes in. Also, that's the way it's displayed in Excel too. Like if I do, let's see, left. how do we do this mid left? I forgot how to do padding in here. When something like this, give me a second because I know that code is going to run too. Plus two. If when less than 5, comma. And that, I think we can add on the zip code like that. Does that work? No, it doesn't like it. Oh, 00061. Okay, so I got something there. And I think I can put that there and then fill down. Okay, so see, it should have I should have 5 letters in the zip code. And these are letters, by the way, these are not numbers. Even though this looks like a number, it's not a number. And you can't do any kind of math on zip codes, right? It's absolutely meaningless to try to do math on the zip code. It's just a designation for one region of the country, right? So what do we have? Lat's long, city, state ID, state name, and so on and so forth. So that's what comes to us from this data right here, the DF zips. You can download that from this website I gave you at the beginning. All right, if you look over here, DF, that gives you all the SHAP files, and this will give you the DF zips, right? So these are the zips over here. So you can get that and then load that. And this thing just disappeared on me. Oh, it's back. Nice. Okay. So that will give us all the zip codes. And if I go ahead and run that, I can see what this looks like. It says merge with emissions data error. Name cool climate data is not defined. Let me see what is going on here. And then I'm going to go back. I don't like these things that kind of just skip around like this. This was totally working yesterday when I recorded the video, and then there's no noise. And then today it's giving me a weird error. Something doesn't exist. And yesterday it did exist. So I don't know why these things are missing, although I did have to regenerate all this code because I actually deleted it yesterday. I thought the audio was working. It's not working. I don't know what's going on with that. Okay. So anyways, here's all the zip codes, 33,000, right? When we put the mouse over it, we get the pop-up or the tooltip that comes up, right? And if I zoom in, this is going to be a little bit slower because now we're working with 33,000 zip codes instead of just 10,000. Well, you can see it's pretty comprehensive, right? And most of these zip codes are filled in. Now I zoomed in too much. So let me go out a little bit more. And that looks like Connecticut and Long Island to me. If I go down here, we'll get to New York City. That's where I am. Okay, if I zoom in a little bit, we can see all the details for all these zip codes. And you can see how this pretty much matches the sample I showed you at the beginning of the video here when I showed you my motivation for creating this kind of demo here. And if I go down here, I can find my zip code 11101. That's where I am. We have 16.6 metric tons of CO2 emissions. The neighbors 11106 have just about the same. And down here in Greenpoint, they have just about the same over here. A little bit less. No, a little bit more. No less. 12.79. We have 16.61. So we have to kind of get our act together, guys. So that's motivation to clean up your act, literally, to clean up your carbon emissions act. So it's nice how you can zoom in and zoom out on all these different zip codes throughout the United States. Let me see if I have something. Okay. So I'm saying cool climate data. Oh, but I don't need that. So let me see. Let me see where this is coming from, because just give me a minute, because I had to rebuild this whole thing from yesterday. A mess. I mean, like everything is totally working and the audio doesn't work and then nothing works, right? So let me go back here. Okay, so carbon footprint. Let me look at the other file I had, and now it wants to go slow too. Man, I'm telling you, man, this is like just never ending nightmare stuff. So if I go over here, where is my cool climate data, right? Because it literally worked yesterday. So, and what changed here? If I do Control F, and go over here. Okay, so we have that. Oh, and that's exactly the same thing. So that's why I understand why it would work and then it doesn't work. And do we even need that? I'm thinking maybe we don't need that because look at this. If I do this and then this, and then state total carbon footprint. So okay, let me go over here. And this is map DF. Okay, so I think I can just merge these two. I don't even know I had a cool map DF over there. I don't know what that's about. Anyways, let's get this cleaned up. So I think I can get this out and let me just give this a go and see if this will work. And it does. Okay, so I didn't even need the other thing. This is superfluous, extra, and unnecessary. I don't know what that's doing there. I don't know why it would work yesterday and it doesn't work today, but okay. So we have the total carbon footprint. Texas, Pennsylvania, New York, California, and Illinois, presumably from Chicago. That's the biggest city in Illinois, and I think the top 3 in the United States in terms of population. So that's how they make it to the top 5 list there. And if I look over here, we are just basically grouping by state and then summing the total carbon footprint, right? So all the total carbon footprints come from over here. Okay, total carbon footprints, and we're taking everything by the state, merging those together, and then summing all the carbon footprints. Okay, so hopefully that makes sense. It's pretty basic aggregation. And Python in the bottom 5, we have Delaware, DC, which is a district of Columbia. It's not even a state, it's a district. I think they did that. So no state would have superior influence or power over the governments, the legislative, judicial, and what is the other one? Executive branch of the government, right? So it's not state, it's a district. And then you have, I think this is Guam, Virgin Islands, MP. I'm not even sure what that is. Sure what that is. What is MP? It's some kind of U.S. territory. I know that. Northern Marina Islands. I've heard of that. Never been there. I don't know anything about that. And AS is the smallest carbon emitting U.S. territory. And what is that? AS is U.S. territory. Oh, American Samoa. Okay. Gotta love it. So American Samoa makes it to the list, and they emit the least carbon emissions here. So we can go ahead and plot this on a chart and see what this looks like in a basic bar chart. Okay, and then I can go ahead and plot this on a regular geographical map, and we can look again at the what's it called, choropleth map. We can look at the choropleth and see how that looks relative to all the other maps that we saw before we saw all of the zip codes, all of the United States, right? When we look at this big picture, this is macro picture, we're going to see the United States map in all the states around the United States. Here we can see Texas has 26, right? If we go over here, 26,000 metric tons, PA 24, New York 24, California 23, and Illinois 18. And we see the same thing down here. So PA, New York, California, 24, 23.8, and then Illinois rounding up the top 5, 18.82. And that matches exactly with what you see over here, 18.82. Okay, so that makes sense. If we look here at the choropleth map, EF states, now I'm getting this error. So this is great, guys. I don't know why it keeps doing this. Literally, yesterday it's working, the audio doesn't work, and today this thing doesn't work. So I have to look at this DF states and see what is going on here. I'm telling you, man, if it's not one thing, it's another thing over here. I don't know why these things just can't work ever. Guess that would just be too easy. And then My job would get boring really quick, I guess. Let me try to fix this up. Okay. DF states is a GeoDataFrame, contains state boundaries. So I get it, but why was it working yesterday and now it's not working today? So if I go here, GDF states, was that over here? Because this was my original code yesterday. I have GF states. Oh, and I did. GF states merge. But I have just GDF states because it doesn't look like it. GF total. So it's coming from there, right? So let me try this. Oh, I have the states and the abbreviations, all the names there. So I could have dropped that. Let me make this a little more easier to read and pull that up. That. And voila, we got our states. Okay, so this is good. We have the top 5. The darker colors represent more intense emissions, carbon emissions, right, in metric tons. New York has 24,000, 24 for Pennsylvania. Texas has the most, right, 26,180. California is 23,820. We go over here, 26,180, 24,192. 23,280. That's it. 23,280. 23820, 26,180. 26180, 23820. Okay, so I think we're fine here. So now we have the choropleth map of the United States. You can see the high state emissions over here. All the states are filled in, including now I think we lost Puerto Rico, but that's okay. We have Hawaii. We do have Hawaii, so that's nice. So that's filled in. Carbon footprint 1285, right? And Alaska is pretty low, 3218. Based on size of the state, like Alaska is easily the lowest, and Texas is the number 1 in terms of emissions, I think, because they have all the oil, all the gas. You can drive through Texas and you see all the refineries billowing up all that nasty stuff into the atmosphere. So that's what they do down there, I guess. So that's it. So we have the choropleth map. Everything is rolled up and aggregated and summed up in terms of metric tons of emissions. And over here we see the breakdown based on the whoops, let me get the map back, based on the zip code of all of the zips in all the states in the entire United States of America. Okay, you can zoom in, you can zoom out. This is very dynamic, interactive. I love these plotly charts. I love these choropleth maps. This is perfectly designed for these types of things, right? You can see all the detail and all the nuances here. And all the in-between stuff. This is Connecticut coast, Long Island. You can see New York City over there. So mission accomplished, guys. We did what we needed to do, measuring all the carbon footprints and creating a tracker based on zip codes all across the United States. So that's it. I'm going to wrap it up here. Thank you so much for your time. I appreciate it. I like the way that you guys watch these to the end of the video. It helps my utilization, my overall watch time, and hopefully I can monetize this channel pretty soon. I'm trying to get close to monetization, so I haven't earned 1 penny from this YouTube channel, but I'm still trying. I've been doing this for about 1 year, devoted 1 year of my life to this. Still haven't made a penny off it, but hopefully soon. I need more people watching more videos. I have to get to 3,000 total hours of video watched. Getting kind of close, but still haven't hit that mark yet. But I do have enough subscribers, so that's nice. That's one of the 2 criteria that I can check off the box. So that's it. I'm going to wrap it up. I am going to turn off the recorder right now and post this video in just a bit, and hopefully the sound works this time. You have the all the source code. I'm going to upload that in the what do you call this, in this HTML file, and I'm going to upload the video, so you have the video and hopefully the audio this time if everything goes as planned. So yeah, that's it. I'm going to wrap it up here. Thanks for your time, and I'll talk to you guys soon. Take care. Goodbye for now.